Just a review of graphing inequalities. When you graph an inequality, you start by graphing the boundary line in slope-intercept form with either a solid line or a dashed line. So if you have a less than sign or just a greater than sign, it's a dashed line as the boundary line. If you have less than or equal to or greater than or equal to, it's a solid line put down as the boundary line. Then you shade by using either a test point or using the inequality sign as a directive. So if it's a less than sign, you shade below the boundary line. If it's a greater than sign, you shade above the boundary line. So we're going to graph y is greater than or equal to 3x minus 1. So you're going to start by graphing the boundary line, which is y equals 3x minus 1. So to graph that, the y-intercept is negative 1. You put a point at negative 1 on the y-axis. And then from there, the slope is 3. So from that point at negative 1 on the y-axis, go up 3 into the right one, put another point down, and then draw a solid line through those 2 points. Solid line because we have a greater than or equal to sign. Then you shade either above the line or below the line. Now you can use a test point as long as the test point is not sitting directly on the line. You could use 0, 0. That's the easiest test point to use. If you put 0 in for x and 0 in for y into that inequality and it makes a true statement, you shade the side 0, 0 is on. Or if you put 0 in for x and 0 in for y into that inequality, it makes a false statement. You shade the other side of the boundary line that 0, 0 is not on. But the easiest way is to go in the direction of the inequality sign. If you have a greater than sign, again, you shade above the line. So all of those points above that boundary line get shaded. So all of these points in this shaded region are solutions to that inequality, including the points on the solid line. So if it's a solid line, the points on that solid line are solutions to the inequality. If it's a dashed line, the points on the dashed line are not solutions to the inequality. But all of these points in the shaded region and the points on the solid line are solutions to that inequality. We're going to solve a system of inequalities by graphing. So we're going to put two inequalities together and find the solution set to that system. So all the xy values that make both inequalities true. A system of linear inequalities can be solved by graphing. When the variables of a linear inequality represent real numbers, a graph solution consists of a half plane and possibly its boundary line. For a system of two inequalities, the solution is the overlap of the two half planes. So where these two half planes overlap, that is the solution set to this system. Those are the xy values that these two inequalities share. Those are the xy values that make a true statement in both inequalities. So those are the xy values that are solutions to that system. So we're going to start by graphing that y is greater than or equal to x minus 1. To start that, graph the boundary line y equals x minus 1. So to graph that, you put a point at negative 1 on the y-axis, and then from there, the slope is 1, so go up 1 to the right 1, put another point, and draw a solid line through those 2 points because we have a greater than or equal to sign. So if you have the equal to sign, you're making a solid line through those points. Then you shade in the direction of the inequality sign or use a test point. It's a greater than sign. We're going to shade everything above that line. So all those points above that line are solutions to that inequality. Then right on top of that, so on the same paper, right on top of that, you're graphing the other inequality, and where they overlap, that is the solution set to that system. I'm going to separate them, but on paper, they would be right on top of each other. So I'm going to graph y is less than or equal to negative x minus 4, the second inequality of that system. To graph that, you start with the boundary line, y equals negative x minus 4. And to graph that, you put a point at negative 4 on the y-axis. And then from there, the slope is negative 1, so you can go up 1 to the left 1, or you could go down 1 to the right 1, put a solid line through those 2 points. And then you're shading everything below that solid line. All of those points in that shaded region are solutions to that second inequality. But on paper, you're graphing these one right on top of the other one. So what these look like, one right on top of the other, would be this. Now the solution set to this system is this overlap, where those two inequalities overlap. So all these points in the shaded region, including the points on the solid lines, those are solutions to both inequalities. That is the solution to that system. So you don't really get an answer here that you would say out loud. You actually have a picture for an answer, and that picture, that is the answer. That is the overlap of these two inequalities. So where these two inequalities overlap, that is the solution set. All of those points are solutions to that system of inequalities. Going to solve this system by graphing y is less than or equal to 2x plus 2 and y is less than negative x plus 1. So we'll start by graphing that y is less than or equal to 2x plus 2. To graph that, you're going to graph the boundary line y equals 2x plus 2. To graph the boundary line, you start with the y-intercept at 2, and then from there, go up 2 and to the right 1. So y-intercept at 2, go up 2 and to the right 1, put another point down, draw a solid line through those 2 points, because you have the less than or equal to sign. If it's the equal to sign, make a solid line. Then you decide which way to shade. You have a less than sign, so shade all points below that line, or shade down on the y-axis. So all of those points in this shaded region are solutions to that inequality. But we're graphing a system, so the second inequality would get graphed right on top of that one, and where they overlap, that is the solution set to that system. So we'll graph that second inequality, y is less than negative x plus 1. To graph that, graph the boundary line y equals negative x plus 1. Now we just have a less than sign, so we're going to be putting a dashed line down. So start with the y-intercept at 1, and then from there, the slope is negative 1. Go down 1 to the right 1, put another point, and then draw a dashed line through those 2 points because you just have a less than sign. Then you decide which way to shade. You have a less than sign, going to shade all points below that boundary line. So all points below that boundary line are solutions to that system, or to that inequality. All of those points in that shaded region are solutions to that second inequality. But as a system, you're graphing these one right on top of the other. So on paper, this is what it would look like. All of the points in this overlap, where these two inequalities overlap, are solutions to that system of inequalities. Now, you got to be careful on the lines here. You have a solid line and a dashed line. The points on the solid line are solutions. The points on the dashed line are not solutions to that system. So all of these points in the shaded region, including the points on the solid line, are solutions to that system of inequalities. You take any x, y values in that shaded region, put them into both inequalities, it will make a true statement in both inequalities. That is the solution set. I'm going to graph this system of inequalities. X plus 2y is less than or equal to 10, and x plus y is less than or equal to 3. But they're not in slope-intercept form quite yet, so you have to get them in slope-intercept form in order to graph those. And watch your sign, watch your inequality sign, because whenever you multiply or divide by a negative number, you change or switch or flip the inequality sign. So as far as the shading goes, sometimes that sign will change. So don't decide on which way to shade until the inequality is in slope-intercept form. So we'll take that first inequality, x plus 2y is less than or equal to 10. To get that in slope-intercept form, subtract x from each side, have 2y is less than or equal to negative x plus 10. And then divide each side by 2, you're dividing each term by 2, so it would be y is less than or equal to negative 1/2 x plus 5. So to graph that, you're going to start with the boundary line, and it's going to be a solid boundary line. Put a point at 5 on the y-axis, that is the y-intercept. And then from there, the slope is negative 1/2. So from that point at 5 on the y-axis, go down 1 and to the right 2 and put another point and draw a solid line through those 2 points. Then you decide which way to shade. Shade using the sign when it's in slope-intercept form. It's a less than sign, so you're shading everything below that solid line. So all those points below that solid line, including the points on the solid line, are solutions to that inequality. Then you need to graph the second inequality, x plus y is less than or equal to 3. To graph that, get it in slope-intercept form, subtract x from each side, end up with y is less than or equal to negative x plus 3. So to graph that, you start with the boundary line, y equals negative x plus 3, put a point at 3 on the y-axis, and then from there the slope is negative 1. Remember, you're graphing these one right on top of the other one on paper so that you can see the overlap. So from that intercept of 3, go down 1 to the right 1, put another point, and again, since we have the less than or equal to sign, we're drawing a solid line through those 2 points. Now, which way to shade? Shade based on the sign when it's in slope-intercept form. You have a less than or equal to sign, so we're shading all points below that line. So all points below that line, including the points on that line, are solutions to that inequality. But what we want here is the overlap. We want the solution to this system of inequalities. So these two right on top of one another, the overlap, that is the solution set that we're looking for. So all of those points in that overlap, including the points on the solid lines, are solutions to that system. You pick any x, y values in that overlap or on those solid lines, substitute into both inequalities. It will make a true statement in both inequalities. That is the solution set. Which point lies in the solution set for the system y is less than 5x minus 1 and y is greater than or equal to 7 minus 3x? So you have two choices here. You can either graph both of these inequalities and see which of these points lies in the overlap, or you could do substitution where you substitute these x, y values into both inequalities and see which point, which set of x, y values makes a true statement in both inequalities. I'm going to take the graphing route here. I'm going to graph y is less than 5x minus 1. So to graph that, you graph the boundary line y equals 5x minus 1. Put a point at negative 1 on the y-axis, that is the y-intercept. And then from there, the slope is 5, so go up 5 and to the right 1, put another point. And we're drawing a dashed line through those 2 points because you have the less than sign. And with the less than sign, you shade all points below that dashed line. Now the second inequality, y is greater than or equal to 7 minus 3x. Now don't get confused here. This 7, that is the y-intercept. That's the constant term. The slope would be negative 3. So to graph that, graph the boundary line y equals 7 minus 3x, or y equals negative 3x plus 7. Start at the y-intercept, put a point at 7 on the y-axis. Then from there, the slope is negative 3. So from that point at 7 on the y-axis, go down 3 into the right 1, put another point, and draw a solid line through those 2 points because you have the greater than or equal to sign. So solid line through those 2 points, you have a greater than sign, so we're shading everything above that boundary line. So that is the graph of the second inequality. Now in the solution set, that's these 2 inequalities put together as one. So you want to graph these 2 inequalities, one right on top of the other, and then look at the overlap and see which of these points lies in the overlap. So if you go through and decide which of those points lies in the overlap, 4, 4 would be the right choice, because if you go to the right 4 and up 4, that point is in the overlap. If you check the other ones, negative 5, 1, you can be going to the left 5 and up 1, that point is not in the overlap. 2, negative 3, if you go to the right 2 and down 3, not in the overlap. And 1, 6, go to the right 1 and up 6, almost, but that is not in the overlap. Very close, but not quite. So in the overlap here would be the point 4, 4. Letter C is the answer to that.